Hi, I'm Corey Todaro, Senior Product Manager for Healthcare at Digital Asset. I want to thank the DID Alliance for inviting me to discuss a very important topic today, and that's avoiding silos in DID systems using a technology called Canton. The work of the DID Alliance and its Global Architecture for Digital Identity, or GADI, is based upon the proposition that interoperability between DID systems is essential to help drive adoption of DID systems, especially in the context of governmental organizations and enterprises. The problem of blockchain to blockchain interoperability is a long-standing one, and work is still being done on how we can solve that particular problem. Digital Asset has one way of addressing this issue, and we think it models well onto the overarching framework of GADI and can provide a solution to provide interoperability between disparate DID systems and to provide specifically governance layers and other functions that are inclusive of the GADI vision. And we'll hope that today you'll get an understanding of the promise of Canton towards the goals of the DID Alliance and GADI. I want to discuss this topic in three discrete steps today. First, I want to introduce you to the work of Digital Asset, specifically our programming language DAML and our application framework for multi-party applications. Second, I want to explore the problem space of DID and understand why siloization is an issue and how might we best look to address it. And third and finally, I want to discuss Canton, Digital Asset's interoperability synchronization protocol that can allow disparate blockchain systems to transact, and how that ties in with the overarching goals of the DID Alliance and GADI. So looking at the first topic, who is Digital Asset and what is DAML? Digital Asset is a company that's developed cutting-edge technology to help enterprises adopt digital ledger technology and address problems of multi-party applications. In blockchain, this is often referred to as smart contracts. How can we have multiple parties securely and in a transparent fashion interact with each other across distributed systems? Digital Asset began that work in 2014 with the key innovation of DAML. DAML is an open source, platform-independent programming language that's been designed specifically for building distributed multi-party applications. Unlike the kinds of languages you bring to other blockchain protocols to write smart contracts, whether that's Solidity for the Ethereum ecosystem, or the various system-level programming languages you can bring to Hyperledger Fabric or Corda, DAML was designed specifically for writing multi-party applications. It focuses on two key problems present in writing smart contract applications today. And the first is that most development work on smart contracts is undifferentiated. And what I mean by that is that a lot of the time that developers spend writing smart contracts have very little to do with the business logic and the security protocols you want to put in to that multi-party application. In other words, we don't spend so much time modeling how the parties interact and the checks and balances that have to come into play to ensure that those interactions are secure. A lot of smart contract from a code level is about how the smart contract talks to the underlying blockchain. That layer of code doesn't have to be written with DAML. DAML is focused purely on the business logic or the business case to be addressed and modeled in the smart contract. All concerns about how it talks to a node, how the nodes speak to each other or come into consensus are taken out of the developer's hands. They don't have to address it. This has two important consequences. One, it enables developers to be a lot more productive. DAML code can be incredibly concise, often more concise by an order of magnitude when compared to smart contracts written in Kotlin for the Corda platform, or when written in Java, for example, or Go for the Hyperledger platform, or Solidity contracts, because there's simply less the developer has to account for. The second important implication is that the interaction or the integration between DAML and these blockchain nodes is handled by our integration engine, which enables us to port DAML applications to multiple different blockchain protocols. As of this recording, DAML integrates with over 10 blockchain and database platforms, including PostgreSQL for centralized applications, Corda, VMware Blockchain, Hyperledger Fabric, Hyperledger Sawtooth, and the list goes on. We also plan to continue to grow that list such that the developers of a multi-party solution don't have to select their underlying blockchain platform to get to work. And we're free to port our application to any of the supported infrastructures that DAML currently integrates with. The second important implication of the structure of DAML is that it drives implementations to achieve interoperability, where independent implementations of the same smart contract application are automatically siloized on other or native blockchain platforms. For example, I can write a smart contract application for Fabric using their native chain code structure and write that in Go. If I have two companies who use that application with separate networks, those applications are siloized from each other. They fundamentally can't talk to each other unless those two networks come together and jointly participate in operating the Fabric network. Blockchains themselves are creating new business silos. And DAML was created specifically to help connect these growing islands that are built on top of distributed ledger and blockchain protocols to achieve true global network capacity and global composability between those disparate implementations. We have perfected DAML, integrated into a wide variety of blockchain protocols, and we're now seeing widespread adoption. In Asia alone, our flagship project with the Australian Securities Exchange is rebuilding the entire core settlement engine, clearing and settlement engine for that security exchange on DAML. Just last week, we announced the exclusive use of DAML for China's blockchain services network. We've done work with the Hong Kong Exchange. We've just issued a multi-million-dollar bond using DAML in cooperation with the Singapore Exchange. My work in healthcare is also taking root in Asia, in the Americas, and in Europe, utilizing DAML on a wide variety of blockchain platforms and database platforms. DAML gives enterprises the freedom to choose the most appropriate technical infrastructure to support their smart contract use case, whether that's Corda, whether that's Hyperledger Fabric, VMware Blockchain, or simply a centralized database. DAML will operate in exactly the same way. I'd like to turn now to talk about the problem in the DID space, specifically around siloization and the problems that introduces to growing and really driving adoption of DIDs. The work of the DID Alliance is centered around the global architecture for digital identity, which seeks to address a wide range of problems that still persist in the DID landscape, despite the really great advances that are being made in the underlying protocol and structure of the decentralized identifiers and the means to both issue those identifiers as well as verify those identifiers. There's fantastic open source work being done around the world on those specific issues, but they're leaving gaps in the end-to-end DID architecture as it's emerging, and the DID Alliance, and specifically GADI, is being designed to address those specific issues. Those three main areas that the DID Alliance and GADI is seeking to address are trust sourcing for digital identifiers. In other words, having an assurance of not only of who issued that credential, but also how that credential was issued. What process, what assurance levels can that enterprise, the issuing enterprise, give to other consumers of that identifier to help them understand that this is a valid credential to meet a variety of regulatory structures. In other words, if an issuer of a DID is claiming that they ran a know your customer or a KYC process on that, how does the consumer of the DID know that? And can we build infrastructure to provide that assurance? The second major area that the GADI is seeking to address is cross-ledger transaction support. And this gets to the core issue that's arising in the broader blockchain space, which is that disparate implementations of DID are becoming the new silos and islands. With projects like Hyperledger Indy, Sovereign, Civic, Uport, these are fundamentally uninteroperable DID systems, such that when an issuer writes to one of those platforms, there is no guarantee that other platforms can use that DID or that enterprises can access that DID. Interoperability and cross-ledger transaction support allows us not only to locate all of the identifiers that a user might have written to different platforms, but also to build important infrastructure on top of the DID use case. That's around governance, that's around trust anchors and assurance levels, and it also helps us build an economic ecosystem around the issuance and consumption of decentralized identifiers. So the siloization of DIDs, or decentralized identifiers, on different protocols is posing a problem for enterprises who wish to adopt DID. Essentially, enterprises have to make a bet. They have to understand the full range of options on where to issue those DIDs, and they have to select one hoping that it has the widest adoption in the enterprise or the industry that that enterprise plays in. GADI, like DAML more broadly, wants to liberate the enterprise from having to make that decision or to limit the consequences of that decision by ensuring interoperability between disparate ledger platforms. An enterprise can move confidently forward with the understanding that they will never be locked out of the growing ecosystem that would issue and utilize decentralized identifiers. But how do we achieve this ledger interoperability? And that's where we come to the third part of this presentation, where I want to explore Canton. Canton is a digital asset secondary synchronization protocol that enables DAML integrated blockchain ledgers to interoperate with each other. If you're familiar with the architecture of GADI, then the architecture of Canton will not be too difficult to understand. The GADI ecosystem is built upon what we call digital address providers. These are individual DID blockchains that allow issuers to record DIDs, that allow users to access those DIDs, and allow service providers to consume those decentralized identifiers for their own business processes. GADI hopes to unite dApps or allow them to speak to each other, such that a service provider hooked up to one DID platform can consume identifiers that are stored on a different dApp platform or digital address provider platform. It also enables users to be able to provide a unified access to all of their identifiers, no matter where they're written. It can be written on dApp A or dApp B or dApp C. And the bridge between those dApps is GADI. The Canton architecture that the digital asset has developed is very similar. Canton essentially is a network of what we call participant nodes. Those participant nodes communicate across what we call a Canton domain, which provides essential services to talk to other participant nodes. Importantly about Canton, a participant node is simply a server that provides users with a consistent access to the DAML Ledger API. That participant node could be a database, or it could be a blockchain. It could be a Hyperledger Fabric, or a Corda, for example, or any of the infrastructure that DAML currently integrates into. The domain, by contrast, is a distinct set of services that is also technology agnostic. It provides total ordering services to guarantee delivery to multiple participants on multiple different participant nodes. And it means that participant nodes communicate with each other by sending end-to-end encrypted messages through that domain. The domain service essentially establishes trust to know that all transactions between those blockchains are atomic, that they're properly ordered, that there are no conflicts between those transactions, and importantly, the domain doesn't see the contents of those transactions. It's essentially offering a service to multiple blockchain networks to be able to interact with each other without centralizing all of the information, nor requiring a third party to see the contents of that transaction. If we take these ideas and we apply it to the dApp ecosystem that's growing up under the GADI framework, we can see that participant nodes are simply dApps. They can be DID platforms of any DAML integrated ledger or database. And the essential services of GADI are to enable those dApps to speak to each other, to locate decentralized identifiers on other platforms, and to also provide a framework for economic rationality around issuing and consumption of DIDs. It is through the Canton domain that we can provide secure interoperability between those multiple independent platforms, and to enable us to have a foundation for the infrastructure of trust anchors to know who is issued that decentralized identifier and what process was applied to issue that identifier, as well as payment arrangements that can be negotiated between issuer and service provider. It is through the interoperability functions that Canton can bring to the GADI ecosystem that GADI can drive towards its vision of driving broad-scale global adoption of decentralized identifiers for all citizens of the world and for enterprise and industry use cases. I'd love to invite you to reach out to learn more about DAML and Canton and our work with the DID Alliance, and we hope to be talking with you again soon. Thank you.